What is the characteristic of redox reaction? There electrons will be produced. Where electrons will be produced? In the oxidation reaction. Where those electrons will be used? In the reduction reaction. What all the processes you have seen now? That 4 process: addition of oxygen, removal of hydrogen, addition of electronegative element, removal of electropositive element. These are the 4 ways of oxidation to understand. Usually metals will lose electrons. So, everywhere if you observe, metals are present. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today, I am going to start a new chapter, that is Redox reaction. That is from Unit 8 Redox reaction. First we will see the exam corner. Total number of hours required to complete this chapter is 5 hours. And you know the question paper pattern. In that part A, part B, part C and part D will be present. In part A, 1 mark question. From this chapter, 1 question will be present. For 2 mark, there is also 1 question, and from 3 mark, there is also 1 question will be present. Overall, the total marks allotted for this chapter is 6. This is about the exam corner or the marks allotted for the redox reaction chapter. First we will see the exam corner. The number of hours required to complete this chapter is 7, and the number of marks allotted for this chapter or weightage of this chapter is 4 mark from your CBSE board. And in the today's session, what we are going to discuss means the introduction part of redox reaction. In that, what is oxidation, what is reduction, what do you mean by reducing and oxidizing agent? These are the contents which we will discuss in the current session. First we will see what is redox reaction and what is the concept behind it. One of the most important classes of chemical reaction is the reduction and oxidation reaction. Usually redox reaction, why we will call? Redox means there are 2 kinds of reactions are present, reduction and oxidation. Sometimes it will happen simultaneously. So, those kinds of reaction we will call it as redox reaction. More commonly known as redox reaction. Redox reaction is the driving force behind a vast range of both desirable and undesirable. What do you mean by desirable? For example, breathing in mammals. Okay, this is the desirable reaction which is example for redox reaction, and undesirable means, for example, rusting of iron process. It is not needed or completely undesired, but also in environment it will happen. A redox reaction is characterized by the fact that electrons are produced in an oxidation reaction are used by the reaction in a reduction reaction. What is the characteristic of redox reaction? There electrons will be produced. Where electrons will be produced? In the oxidation reaction. Where those electrons will be used? In the reduction reaction. These reactions are accompanied by energy changes in the form of heat, light, electricity, etc. This is a very important reaction, and also there is a wide range of applications behind this reactions. So, this reaction will be accompanied by the energy changes in heat, light and electricity and etc. Generation of electricity in batteries and many industrial processes such as production of caustic soda, potassium permanganate, that is KMnO4, extraction of metals like sodium, potassium and aluminium are common examples of redox reactions. In the before slide we have told this reaction is very useful in energy changes like heat, electricity and light, and so many in others examples also. In the generation of electricity like in batteries and many industrial processes also, this redox reaction is very much important, like extraction of metals like sodium, potassium and aluminium and other metals also, and production of caustic soda, potassium permanganate, like this so many compounds will be produced by using redox reaction. In order to understand redox reactions, we must first understand the difference between oxidation and reduction, and then figure out what is being oxidized and what is being reduced. Yes, before going to understand the complete redox reaction, you have to bifurcate what is oxidation, what is reduction, and you have to understand individual reaction mechanism. Then you have to see the overall net reaction. Without understanding what is oxidation, what is reduction, which electrons are getting to produced, where it has been used, if you doesn't understand that overall concept, it is that overall concept to understand redox reaction is little bit difficult. And you have to analyze which element has been oxidized and which element is being reduced also, you have to notice and understand. First we'll see what is oxidation. This oxidation procedure or process you have seen in your previous classes also. We'll see now. During oxidation, removal of electrons takes place in different ways. So, oxidation is a process in which any one of the following changes takes place. During oxidation, removal of electrons will takes place in so many ways. We'll see how. Addition of oxygen, removal of hydrogen, addition of electronegative element and addition of electropositive element will be seen. We'll see one by one. Addition of oxygen. This is magnesium. Any metal you can take. Addition of oxygen is going to happen, and MgO, oxidation of magnesium is going to happen. This is getting oxidized. And sulfur plus oxygen, sulfur dioxide. See, oxidation of sulfur is going to happen. This is the example of addition of oxygen. Next, removal of hydrogen, dihydrogen sulfide, that is H2S, and chlorine is going to react. Okay, here removal of hydrogen is going to happen. See, one hydrogen is removed and going to react with chlorine, and sulfur is getting separated. Oxidation of H2S is going to happen. Next, addition of electronegative element. Electronegative element means most electronegative elements are in group 17, that is halogen group. Here magnesium chloride means oxidation of magnesium is going to happen. Here magnesium plus fluorine, magnesium fluoride will form. Here also magnesium is going to oxidized. Magnesium plus sulfur, this is also electronegative element because it is in p block element. So magnesium sulfide, here also again magnesium is going to oxidized. Okay, these are the three ways. And another way is removal of electropositive element, where usually electropositive element will be present in S block elements, that is group 1 and group 2. Here see, overall aqueous complex is present. Here electropositive element is potassium, since it is present in S block element. Here that potassium is going to remove. Here K4 is there, see here K3 will happen. Removal of electropositive element is going to happen. So oxidation is defined as the addition of oxygen or electronegative element to a substance, or a removal of hydrogen or electropositive element from a substance. In this way you can define. Once again I am telling, oxidation is defined as addition of oxygen or electronegative element. You can add to any substance oxygen or electronegative element, or from any substance you can remove hydrogen and electropositive element. So overall that process will be considered as oxidation, and which substance is going to be added or removed, that substance will be considered as oxidized. Okay, this is about the oxidation. And usually you have seen so many examples from your previous classes also in your daily life, like rusting of iron or corrosion of any metals or iron usually, and rancidity, that oil will going to get oxidized, rancid will form. These are some of the examples of oxidation process. And also if you cut an apple, if you keep it in a open atmospheric oxygen, that iron usually will turn up into brown color. Why it will happen? Because of oxidation process. These are the usual, in our daily life we will see those examples, but behind that examples we have to analyze the concept. Next is reduction. Reduction is just reverse of oxidation. Okay, what all the processes you have seen now, that 4 process: addition of oxygen, removal of hydrogen, addition of electronegative element, removal of electropositive element. These are the 4 ways of oxidation to understand. Here, those are all removal of oxygen, removal of electronegative and addition of hydrogen, addition of electropositive ways can be seen. So, what they are telling? Reduction is just reverse of oxidation. Yes. Reduction is a process in which any one of the following chemical changes will take place. As I told, removal of oxygen. See here, from that mercuric oxide, oxygen is going to removed. Okay. Reduction of mercuric oxide will be seen. Next, removal of electronegative element. Here electronegative element is again chlorine only. From ferric chloride and hydrogen is going to reacting. So, from that ferric chloride, one chlorine atom will be removed and attached to that hydrogen. Reduction of ferric chloride will happen. Next, addition of hydrogen. This is ethene. For that, hydrogen is going to added means what will happen? Ethane will form. Here, reduction of ethene will seen. Addition of metal means electropositive metal or element. Mercury chloride, for that tin reacting with tin chloride, that is mercury chloride plus tin chloride. Okay. Reduction of mercuric chloride is going to happen. These are the 4 ways, and which is a reverse of oxidation process. You have to analyze and you have to compare yourself with oxidation and reduction. So, reduction is defined as the removal of oxygen or electronegative element from a substance or addition of hydrogen or electropositive element to a substance. Okay, once again, what do you mean by reduction? Addition of hydrogen or addition of electropositive element to a substance, or removal of oxygen or removal of electronegative element from a substance. Okay, again that substance will what will happen? It is going to reduced. These are the 4 ways of reduction. Next, we will see redox reaction in terms of electron transfer. As we have told earlier only, there is an electron transfer process. Okay. Now, you have to understand that if reduction and oxidation is going to happen simultaneously, what will happen? In terms of electron transfer reaction. Reactions in which electrons are transferred from one atom to another atom are called oxidation reduction reaction. In reactions, usually we know electrons are going to transfer from one element to another element. So, that will be considered as oxidation and reduction reaction. So, loss of electron is called oxidation and gain of electron is called reduction. Okay. Loss of electron will be considered as oxidation, gain of electron will be considered as reduction. An easy way to identify which substance is being oxidized and which substance is being reduced is the the acronym oil rig. Okay. How? Oxidation is loss, reduction is gain. If you know this acronym or if you know this overall phrase, you are going to understand the complete reaction or complete redox reaction, because for one mark you have to analyze which element is going to oxidized or which element is going to reduced. To identify which is oxidized or which is going to reduced, if you know this overall trick, you can able to identify. Atoms that lose electrons are being oxidized. Okay. From which substance or from which element the electrons are going to lose, that atoms or that element will be considered as oxidized. Atoms that gain electrons are being reduced. Which substance will gain the electrons will be considered as reduced. We will see one example. See here, this is sodium and this is chlorine. To form sodium chloride, here loss of 2 electrons is going to happen, and here gain of 2 electrons will going to happen. Here loss of 2 electrons, here gain of 2 electrons. Then this is going to oxidized and this is going to reduced. Like this you have to analyze. Okay. See here, Na plus Cl minus. Usually in chemistry, plus sign if it is present on any element, their loss of electrons has been done. Or minus sign is present on any element, their gain of electrons has been happened. So you have to check like that. See here sodium is oxidized whereas chlorine is reduced in the before example. Next example 2, sodium and oxygen. Here also same, sodium is going to oxidized, okay, because loss of 2 electrons, this will going to oxidized. Here gain of 2 electrons, oxygen is going to reduced, okay. Here you should not get confused because oxygen is present, it will going to get oxidized. No, oxygen is an element. Here for the oxygen itself gain of 2 electrons is going to happen, so it will going to reduced, okay. For any element if you add any oxygen, there you have to understand that element will be oxidized, so you should not get confused. Next in example 3, sodium and sulfur. Here also loss of 2 electrons, so sodium will be oxidized. Sulfur gain of 2 electrons, sulfur will going to reduce. Usually metals will lose electrons, so everywhere if you observe metals are present, okay. For our convenience, redox reactions can be written in 2 separate steps, one involving loss of electrons called oxidation, half reaction, and other involving gain of electrons called reduction, half reaction. What they are telling? Usually redox reaction can be written in 2 reactions for our convenience to understand the electron transfer mechanism. If the loss of electrons is going to happen, that will be considered as oxidation, half reaction, and if gain of electrons is going to happen, reduction, half reaction will be considered. At the end, overall net reaction will be written. We will see one example or illustration, formation of sodium chloride. Here sodium, loss of 2 electrons, we have seen previous example also. What will happen? From sodium, plus will be written. Here 2 electrons means 2 electrons will be or lost. Here chlorine plus 2 electrons means 2 electrons will be gained. Here see 2Cl minus. Each of the above steps is called half reaction, which shows involvement of electrons. Sum of the half reaction give the overall reaction. This is one half reaction, this is one half reaction, but this is oxidation half reaction, this is reduction half reaction. After that, by taking 2 half reaction or by the sum of 2 half reactions, the overall reaction 2Na plus Cl2 will happen 2Na plus 2Cl or 2NaCl. Okay. Next, reducing and oxidizing agent. You know now what is oxidation, what is reduction, and overall what is the electron transfer mechanism and how it will be done. But to do oxidation or to do reduction, you need some influence of some other substance. That substance will be considered as oxidizing agent or reducing agent. A substance that can readily lose electrons to other substance is called reducing agent or reductant. Okay, you should not get confused. If any substance is going to lose any other substance, that is not oxidizing agent, that is reducing agent, because it is reducing or it is eliminating or deleting to some of the electrons from other substance. So that substance will be considered as reducing agent or reductant. A substance that can readily lose electrons to other substance. You should not get confused. The substance which will lose electrons from other substance will be considered as reductant or reducing agent. A substance which will make other substance to gain electrons will be considered as oxidizing agent or oxidant. Okay. See here, a substance that can readily accept electrons from other substance is called oxidizing agent. It is not reducing agent. It is influencing other substances. So it will be changed. So reducing agents are electron donors and oxidizing agents are electron acceptors. Okay. Once again, reducing agents are electron donors. From it only it will donate electrons, but oxidizing agents It will accept electrons. So, electron acceptors. Here reducing agent, see here hydrogen and oxygen. Here loss of electrons will be happening. So, it is a reducing agent. Here gain of electrons will be happening. So, it is a oxidizing agent. But overall the oxidation process will be happening here. This is reduction will be happening. Little bit difference is there, but you should not get confused. In example, see here another example, ferric oxide. This is aluminium. Aluminium is a reducing agent because it is gaining electrons. So, loss of electrons is going to happen. Here oxidizing agent, reduction is or gaining of electrons is happening. Here also H2S, here ferric chloride, here gain of electrons. So, reduction, here this one will happen, reduction, this one will happen, oxidation. Here ferric chloride will be seen. I hope you have understood completely whatever the reduction, what is oxidation, what is redox reaction in terms of electron transfer method, okay, what is oxidizing agent, what is reducing agent, everything. In the next class, what is oxidation number or oxidation state? Next, rules for assigning oxidation numbers. This is very important chapter for your examinations, children. So, better understand, and this is very much basic chapter to understand how to analyze the oxidation numbers also. For that, we will meet in the next session. Thank you.